Okay, two particles P and Q of masses 0.5 kilograms and 0.3 kilograms are connected by light in extendable string with the string is taut and P is vertically above Q. So there's my diagram. A force of magnitude 10 newtons is applied to P vertically upwards. So let's put that force in. Straight up, 10. Okay, we've also got the weight of P. Okay, the weight of P is mg, mass times acceleration due to gravity. So it's 0.5 g. So what I'm going to do there, 0.5 g, 0.5 times 10 is 5. We've also got the weight due to gravity of Q. Well, it's going to be 0.3 g, 0.3 times 10, which is 3. Now, what other forces have we got? Well, we've got the tension in the string. That's more difficult to understand tensions. Or from P's point of view, the tension is definitely pulling down. So there you go. Now, from Q's point of view, the tension is actually pulling up, because if the string snapped, then Q would just be in free fall, wouldn't it? So the tension's actually pulling up. The tensions are exactly the same, okay, because we're assuming it's a light inextendable string. There you go, a light inextendable string, which means the tensions will be the same. So if you take it as a whole, the two t's will cancel out, won't it? If you resolve upwards or downwards, the t's would just cancel each other out. But if you just consider P, then you're only using this tension. If you're considering Q, you're only using that tension, okay? Find the acceleration of the particles and the tension in the strings. Well, let's work out the acceleration first. Okay, now which way is it moving, up or down? Well, it's not always obvious, but there seems to be more, if you forget about the tensions because they cancel out, there's more force going up. We've got 10 going up and we've got 5 plus 3 going down. So let's assume it's going up. Now, if you don't know, it doesn't really matter, because if you get it the wrong way around, it will just be negative. So it's going up. So we're going to consider up as positive. So there's our acceleration, up. Okay, so up is positive. Now we've got three choices here. We can consider the whole thing as a whole, in which case the t's will cancel out. Or we can consider just the P, in which case the T will figure, or we could just consider Q, the T will figure. Well, the great thing about applying it as the whole system is the T's will cancel out. Okay, the acceleration as the whole is A, the acceleration of P is A, and the acceleration of Q is A. But let's consider as a whole. Right, we're considering as a whole, and we're going to resolve up. Okay, R means resolve up. Okay, and we're going to use Newton's law, F equals ma. Okay, so F, the total resultant force going up, equals the total mass times the total acceleration. Well, the total force going up, well, we've got 10, positive 10. Okay, we've got minus 5. Okay, we've got minus t, we've got plus t, and we've got minus 3. Well, notice the t's cancel out, so there's no point, there's no need to involve the t's. So we've got positive 10, minus 5, minus 3, equals the total mass, which is 0.8, times A. So 2 equals 0.8A. So A is 2 divided by 0.8, which is 2.5 meters per second. Right, to find the tension, we have to we can't consider the whole system because because if we consider the whole system, the t's will cancel out. So we either have to consider P or we have to consider Q. It really doesn't matter. In some ways, Q is the simplest one. Okay, I'll demonstrate it with considering P, but you'll get exactly the same tension. Okay. Okay, now do put your notation in, say what you're doing. If you do make mistakes, the examiner can look back and give you credit, okay? So do say what you're doing. You're saying what you're considering P, so considering just this bit. So it's almost as if you can draw a dotted line here, okay? And we're just looking at this. That tension will account for all of that. Okay, if that weight suddenly increased, that would affect the tension. So that tension is as a result of what's happening here. So by having that tension, you can forget about this bit and just look at this alone. Okay. Okay, so resolving up on P, okay, we got just P, we got 10, and we got -5, and we got minus T equals the mass of P, 0.5 kilograms, times this same acceleration. Now, if we consider Q, we'd have T minus 3 equals the mass times acceleration. Right, going back to P, 10 take away 5 is 5, so we've got 5 minus T equals 0.5 A. What was A? A is 2.5. Okay, so solving that, you find that T is 3.75 newtons. And if you solve this, you'll also find that T is 3.75 newtons.